Find memory integer 15 as time 1 of 5 and following 2, 3, 4, and 5. Okay, so just like before, but now we have the time. So as far as our example data goes, 3 pieces of information, the date and the time. We have all the information we need to log to the table. Let's just go ahead and give a quick description to what we're going. So this is our timer function. Okay, and we'll give it space here, but we'll fill this in a bit. Okay, so 3 pieces of data, date and time. The next thing we need to do is use our data table tool to write row. Let's take a look at how this works. I want to place it down here and just leave ourselves some space. So this is the configuration menu we get when we use our data table write row. We're going to select from tables the table we want to use. If we had more than one, again, we saw earlier that in the data table configuration we created 2. They would show up here. In our case, we only have 1. Now, since we're writing to the row, we have to link a couple more pieces of information to this function. First, we have to tell it what row we want to write to. And now remember, the first row is 0. That means out of 100 rows, the last row is 99. We're going to use a memory integer to do this. And again, I'll select the next unused address. We'll call this row index. And in this case, in this example, I do want it to start at 0. You might not always want it to start at 0. If you don't want the table to start from the beginning every time the controller resets, don't do this. But in this case, I do, so I want to be able to see it. So I'm going to hit OK here. We'll take a look at what we do with this in a second. But we now have the column for date, time, data bit, data int, and data long. Notice this column source operand is still blank. This was populated from the structure of our specific table, and it's nice. It reminds us of what we put there. We don't have to go back and look. Let's go ahead and link the date to our memory integer 10. Okay, so when typing in, if we don't remember this is memory integer 10, we've got a few options. One is to scroll through the entire list of memory integers, which is okay. If we don't really remember what we have, this is a good option. I can select MI10 here, but one of the nicer options is programming with names here. I can just type in, oops, I'm sorry, we need to be using date. I can just type in date. It's going to pull up every operand with a description that has the word date in it. So we have a system integer, 3 system double words, and of course the 5 that we've defined with the word date in it. Again, when we're working with strings or vectors, we have the start of vector. In this case, it's MI10. Okay. For the time, we'll do the same thing. We'll type in time. There's a couple more variables that use the word time in them, but it's okay. Memory integer 15. It's easy for us to find it and see. Now, the data bit, again, our Boolean type is a bit. We're going to use a memory bit. Notice that the system is nice enough to change the data type to memory bit and at least list list that as what we're going to use. And again, we gave these all 0, so I can just type that. The data int, again, it's an integer. It's left us with memory integer. Again, memory integer 0. And long, memory long 0. Okay. So what did we just do there? We selected our table. We defined the row index. Again, since this is the write tool, this is the row that we're going to write to. And we've linked a pointer to all of the registers in our system that we want to write into the table. Okay. So I'm going to go ahead and hit OK here. Good. We've defined our write row. So in this net, every second, we are going to save the date, the time, and then we're going to write it to the table. So let's go ahead and let's connect these elements. Again, I double-click to bring up my connect elements, or I can click on the connect elements, click and hold down and drag down, and again, all the way to the left. Oops, sorry, not all the way to the left. Just about all the way to the left, and down one, and we'll connect these. Okay. Again, power must go from left to right. If it doesn't, the compiler will have a problem. So, what is the one piece of information that we haven't accounted for the data table write row yet? That would be the row index. So we need some mechanism or some scheme here that's going to take care of incrementing this row index or at least telling it where we want it to go every time. We had it start up as 0. Again, that's what this 0 in the brackets means here. If we want to continue to write to row 0, then this is going to do that for us. But I think we have 100 columns, so we want to write to them. So what we're going to do is use our incrementer tool. And again, that's why this is here. We could use the math and use the add 1, but the incrementer tool very simply is going to increment once. All these functions, by the way, the data table, they're going to be triggered once because our TD0 is only going to be high for one scan, and it's going to go back low for whatever time base we gave it. So we can feel rest assured here that we're going to increment this row index just by 1. So I'll type in row and memory integer 1. Okay, great. So now we have a system that is going to turn on, and it's going to log to the row 0 of the data table, and every second it'll write to the next row. This is great up until we get to row 100, and we have nowhere to write to. So let me double click here again. We'll bring it down. We're going to use a compare function, the greater than or equal. And again, since this is an example, we can do things that we might not always want to do, but are useful to show the functionality of the tools here. So we're going to compare memory integer 1 to, again, the constant here, not the memory integer. So this is the value 100. And so we'll see that when memory integer 1 is above 99, and that's going to mean that we've written to the last row, we're going to come down to this net. And when this is high, we're going to use our reset numeric tool, and we're going to reset the row index. Okay, and again, don't forget to connect the elements. So we're going to write, and we're going to increment when our row index is 98. We're going to store the date, store the time. We're going to write to row 98. We're going to increment to 99. This function will not be active. We'll come back around in the scan. We, at the end of the second, will write the date, write the time, write to row 99, increment row index to 100, and at this point, we'll reset it. This net 6 will be active, and we'll go back to row 0. Okay, so what we're creating is an endless loop. It's going to write to all 100 rows and then start back at the top. Okay, so let's take a second and download this, and we'll use our online view tools to see what's going on in the data table. I'm going to do connection, download, and since we've defined a couple startup values, I'm going to use the stop, download, and reset. This way those values take effect. If we just did a download, we might not reset the row index, for instance. Of course, this function would reset it if it's over 100, but we wouldn't start it maybe at 0. Yes, I want to hit yes to these changing time values. So it's asking us if we want to change, or if we select upload, we'll take the current value of 0, and we'll change it in the program. I don't want to do that. Notice the progress bar we have again in the bottom left. Okay. So our program is downloaded. The controller is resetting. Okay, so the controller is on. What I want to do is go back to the data table, and I want to click here on the online view. And when the data comes in, okay, so this is the first thing that we want to take a look at. Notice that this new data is coming in, but we have garbage here in the previous spots. This is because this PLC was used for a similar purpose, but the structure was not the same in the data tables. What that means is we've defined chunks of space that we look at in the data table, in the memory. It's really not all that important for us to use, but when we see garbage like this, it's because in this case, these are ASCII strings that aren't defined the same. This is a bit, it was a bit previously, this is a memory integer, and this is a long. Okay, so the system can pull out that information, but in terms of ASCII representation, this is just garbage to us. Okay, and again, all it means is that this is, you can think of as one really long line, and we've said with a length of 10, we stop there, and we start reading the next piece of information, length of 10, and then we read the next bit, and we read an integer's worth of data, and a long's worth of data, and then we go back and do the whole same thing again. Again, it's not terribly important, but that's what's going on here. This is garbage information, It's been defined as a different structure than what we're currently trying to read. And it's important to keep in mind that if you have been previously using something for a different purpose and you now define the same structure for the same memory, we probably want to clear it out or use some tool to do that for us. But regardless, we can see that our date is being written into the date column. Our time is being written into the time column. Our data bit, we said it's going to change every second, and we're going to log every second, so we should see it go from 0 to 1 to 0 to 1. Our integer, 102, 103, 104, 105, 106. Our long is increasing by 337. Now this is useful. This is good. We've created a system that's recording data. If that was our only intention, then good. We did it. We're done. But more often than not, we want something that's usable. We want some kind of functionality. Notice I keep scrolling down. I'm kind of chasing the update rate here. We're going to record the 100 last pieces of information. But in this situation, we're not going to display them very well. It's not so good for the user in this case, especially if we have a spreadsheet and we're trying to look at the last 100 pieces of information. Of course, we can create anything in Excel, within reason, to come and parse this out and put it in some other spreadsheet if we want. But let's go ahead and let's edit our example here so it's a little more usable. Okay, so I'm going to leave the online test mode. I'm going to leave here. Changes, yes. I'm just going to, give me 1 sec to save the project. Okay, these are the old ones. I just want to make a new folder. And we'll just call it Data 1. Okay. Now, just to recap what we were doing here, we have our 3 pieces of data. We have our date and time function. And this is our function that is continuously writing to the table, and then it's checking to see when we reach the end of the table, and it's resetting. It's storing a 0 back into that row index. The row index is the one making the decision on what row to write to. So, that being said, I want to edit this and create a shift register type of example. So I first in and first out. What we're going to do is modify the write data table, and it's going to write only to the first row. But before it gets to write to the first row, we're going to shift down all of the information that was previously there. And if this doesn't make sense, we'll have 2 more opportunities to explain it. First will be when we set up the function, and second is when we take a look at the table. But basically, we're going to move everything down, we're going to make space in that first spot, and we're going to put new information there. Doesn't work exactly like that, but we can think of it as that. One thing that's nice to do when we're changing code, modifying code, working with code, we want to make a change to something. We don't necessarily want to erase it. I don't want to erase net 6 here. It could still be useful if I choose to go back to that old structure. But I can right-click, and I can select Disable. And notice that we have green hashes through here now. This is very useful. If I want to do tests, maybe I want to create 3 nets that are almost identical, but maybe one in increments by 1 and one in increments by 2. Whatever we want to do is fine, but I can disable this net, and when I download next, it won't be compiled, it won't go to the PLC, it won't be in the memory, it won't run, but it will still be in my VLP file. Again, this is our Visilogic environment. This specific instance is data1.vlp. Let's just do a quick save as data2 so we don't accidentally overwrite our previous example. But this will allow me to play around, to experiment, and not lose the work I've done previously. Okay. Now, what do we need to do? First is we need to modify the example.